In today's lesson, we're going to examine group data. Often when we're dealing with data, whether it's stuff we collected ourselves or something that someone else has collected, we like to organize it first. We put it into a table. It makes it easier to work with, but it makes it slightly more challenging to calculate our measures of central tendency, mean, median, mode, and spread, standard deviation, variance, quartiles, and things like that. So we're going to look at how we can calculate that based on tables of information. So the first thing you need to ask yourself is, do I have discrete data or do I have continuous data? Because the way we approach it depends on the type of data that we have. Discrete data is actually kind of nice because you already know what the values still are. It just happens to be more than one of them. So to calculate the mean for discrete data, what we're going to do is we're going to take the frequency, how often something has occurred, and the value, and multiply them together. Kind of the same way we did weighted means. We're then going to divide by the sum of the frequencies. Okay. And just, I'm going to come back to this page in just a second here just to show you what we mean. So if I have this data, okay, this is discrete data, look at the number of piglets in a litter. There are 8 piglets, and it happened 8 times. So really, I could write this out 8, 8, 8, 8, 8, 8, 8, 8. There's 8 of them, and then I could go, oh, there's 16 nines. But that would be kind of painful, right? We don't want to do that and type that all into a graphing calculator. So we want to simplify this by using the table. In other words, we want to use the idea that there are multiples of each value. So this would be my frequency, and this would be my value. Okay, so I go back to my weighted mean, my idea, frequency times value, divided by the sum of the frequencies. In other words, how many data values there actually are. Okay, it's actually pretty quick to do. Our mode is going to be the most common frequency, the number that shows up the most. That's kind of common sense. Our median will be the middle piece of data in the table. We can locate that pretty quickly, actually. We'll show you how to do that in a second. Q1 and Q3 will be the middle piece of each half of the table. So once you find the median, Q1 will be we have our low, we have our median. Q1 will be the halfway point of those things. And Q3 would be the halfway point between the median and the high. And again, we can find those pretty quickly. And then our standard deviation, well, it's done the same way. And we're going to let our graphing calculator do the work for us. Just to save ourselves some time there. So let's try an example. Okay, determine the mean, median, mode, and IQR for this lovely set of data. So to do this by hand, our mean will be the value. So there's 8 piglets in this litter. It's a discrete number, and it happens 8 times. Plus, there's 9 piglets in a litter. It happens 16 times. Plus, 10 piglets, 21 times, and so on, and so on. So we're going to multiply basically the same way we did weighted mean. There's 40 of those, and there's 13 and 19 of those, and 14, and that happens 7 times. Just going to move this over here because they're in a room. And there's 15, and it happened 6 times. And we're going to divide that by the total number of pieces of data. In other words, the cumulative frequency. So we have an 8, 16, 21, 33, 40, 19, 7, and 6. Okay, and if we do all that math, plug it all into our calculator, hopefully you get 11.31. Okay, there's our mean. Our mode, that's a pretty easy one to find. What's the most commonly occurring value? Well, there's 40 12s. There's our mode. Right, pretty quick to find that one. Our median, slightly trickier. We have to find the middle piece of data. So one of the easiest ways of doing this is actually add a column to our table. Call it the cumulative frequency. So we have 8 and then 24, and we're adding. And then 45, and then 78, 118, 137, 144, and 150. So I know there's 150 pieces of data. If I want to find the middle piece, where it's located, the middle, remember we had our little formula here, right? N plus 1 divided by 2. the number of pieces of data, so it's 150 plus 1 divided by 2, tells me that I have to find 75.5. The 75.5 piece of data. It's halfway between 75 and 76. So where does that fall? Here's your thinking part, okay? The first 8 numbers are all 8s. The next 16 numbers are all 9. So in other words, the first 24 are 8s and 9s. The first 45 are 8s, 9s, and 10s. The next numbers are all going to be 11s. Every number between the 45th piece and the 78th piece are all 11s. So the median, which is located at 75.5, is in the interval between 45 and 70, somewhere in this interval. And we know all of those numbers are 11. And so it's a bit of a thinking question here for median. Okay, for Q1 and Q3, we got to find the quarter pieces of data. We got to figure out what's halfway between the beginning, 1, and 75.5. Well, we can do that by doing our little trick of adding and dividing by 2. So 1, that's the first piece of data. Sorry, just a bit faster. 75.5 plus 1 divided by 2 is 76.5. So in other words, 38.25. Where's the 38th piece of data? Well, that one is after 29, after this, which is all this 8s and 9s, but before we get to 45. So Q1 would be 10. Okay. Q3 is a little trickier to find. And the easiest way I would suggest to find it, if this is Q1, that's where it's located, and this is the median, that's where it's located, the halfway point, Q3 will be the sum of these two things. If I add 38.25 onto 75, we get to 113.75. Well, 113.75 is located after 78, but before 118. And remember, we're doing 38.25. We're going to add them together and we'll get 113.75. That's located in this interval between 78 and 118. In other words, all the numbers that are 12s. So Q3 is 12, which makes my I, QR, Q3 minus Q1, 2. Okay, so it's not horribly hard to find, kind of a little bit time consuming. So let's go with some technology, right? We can do this by hand, nothing wrong with doing it by hand. We can know where they come from, but we know technology is a faster tool. So let's look at another discrete situation. The number of calls to a doctor's office was monitored every hour for a month. The data is shown as follows. So during an hour, they received 6 phone calls 10 times. So we could write out 6 and 6 and 6 and 6 and 6 and write out 10 times. Then we had 42 8s. We could write them all out, but we know this table is faster. To do our technology way, this is our new thing for today. Well, we got to enter our data. So what do we have to enter? Well, we have 2 pieces of data this time. It's one variable, but it's a variable, the number of calls, repeated over and over again. So we're going to go to stat and add it like normal. And we're going to put in our data, 6 phone calls, 8 phone calls, 9 phone calls, 15, 16. But we're going to go over to L2 this time and add some more things in. There's multiples of each of these. There were 10 6s, 42 8s, 31 9s, 63 12s, and so on and so on. Okay, when you get to the end of your list 2, make sure you have the same number of things in list 1 and list 2, that they all match up. Okay, we're now going to go back to our stat and calc and one of our stats, because we're only dealing with one variable, the number of phone calls. Just so happens that some of those happen more than once. Our list, our data is in L1, but the new thing is we have a frequency list. Okay, we have frequencies and there is a list of them. We have to put in L2 here. To do that, second and 2. You notice it has a little L2 right here. So second and 2. And then we're going to go to calculate. Okay, so what do we got? Our mean. Well, it's right there at the top. like normal. 12.48. Our median, we know we have that in our list. We go down the list. That's 12. Our mode, we know that's from the table. The most common number, happens 63 times, is 12. Okay, there's all part A done. Part B, find the standard deviation, variance, range, and IQR. Okay, well, standard deviation, that's something on our graphing calculator. Move this over here so we can see it. Go back up the list. Make sure we're using SX, so 4.23. Our variance is the standard deviation squared, so literally just square it. You should get 17.89. Our range, that's our highest minus our lowest. Now, I don't really need the graphing calculator for this because I can see the highest in the table. The highest number is 25, the lowest was 6. So 25 minus 6 is 19. But it is in our graphing calculator if we do want it. It's down at the bottom again, our min and our max. And then our IQR, which is Q3 minus Q1. Okay, so 15 minus 9. And our IQR is 6. And that's how quickly you can do technology. If you wanted to, we could go back to our previous example and check it pretty quickly and see how we do with our math. So let's go back and try this one just real quick so we can either clear the memory, second plus 712, or stat, edit, and go up to the top and press clear. That works just as fast. Let's see how we did our math here. We got 8, 9, 10, 8. Yeah, it takes longer to type things in than it does to actually do the math now. Stat, calc, one of our stats. We have a list, L1. Our frequency list is L2. And here's what I want to point out for you. This will always stay in here until you clear the memory or clear that. So if you don't have frequencies, make sure you delete that. And go down to it and say, oh, I want to get rid of that. Now, we do want it for this question because we're looking at frequencies. Let's see how we did. 11.31, that's pretty accurate. And we went down here, we found our mode, that's off the table. Our median we said was 11, yep. Q1 was 10, perfect. Q3 was 12, great. Okay, it works pretty quick, doesn't it? Way faster than doing it by hand and having to think about where is the middle of all this stuff. Okay, that's discrete data. Whole numbers, things you count, pretty easy to work with. Let's look at continuous data. The problem with continuous data is you have to put into intervals. Well, if you have an interval of information, so for example, we had 0 to 10, and I had a bunch of data in there, I don't know, maybe I had 6 pieces of data in there, I don't actually know what the numbers are. I just know that they're between 0 and 10. So I don't have raw data anymore. Every time I want to do a calculation now, I can't get the exact answers. I can make really good approximations, pretty good guesses of what the answers are going to be, but my answers are only that, guesses. Okay? So we're going to approximate central tendency and spread. And we're going to do that based on the midpoint of the interval. So the midpoint of 0 and 10, the halfway point would be 5. I'm going to approximate everything in that interval as 5s. Doesn't mean there are any 5s. Maybe all the numbers were 0, 1, 2, 3, and 4. Okay? Or maybe they're all zeros. I don't know. But I'm going to approximate them based on the fact that I think they're 5s, the middle of that interval. Okay? Everything works exactly the same. Okay? So our mean is still the same formula, except for instead of using a value, we're going to use midpoint. Okay? Standard deviation, exactly the same, except for instead of using a value, we're going to use a midpoint. Okay, our graphing calculator still does the same work for us. We don't have to change anything. We just got to remember to put the midpoints in as my estimations of the interval. Mode, okay, remember it's an interval, so we don't usually talk about the interval. We talk about, again, the midpoint. Okay, so everything's the same process, but the idea is these are going to be approximations because they're just midpoints. So let's try one. We have 100 seedlings. They're measured and their heights are recorded. So for measuring things, we know it's continuous. I don't know what the actual heights of these things are. I know in the first interval they're between 1 and 3. They could be 1s and 2s and 2.5s and 2.999s, but I don't know what they are. So I have to approximate it based on my midpoint. What's the midpoint of 1 and 3? Well, if you add 1 plus 3 and divide it by 2, you'll always get your midpoint. 2. Common sense also says 2. Next one is 4, 6, 8, and 10. Those are my midpoints. Okay, we're going to do this with the calculator, save ourselves some calculation time. So back to our graphing calculator, stat, edit. Let's go up and clear these things out and put our new data in. So what do we have? We don't have values, we have midpoints. So 2, 4, 6, 8, and 10 are midpoints. How often did that occur? There were 8 in the first interval, 31 in the second, 42 in the third, 16, and 3. Same old process, stat calc, one var stats. We're going to leave our frequency list in it because we have multiples. To our calculate, and here's our information. What do we got? Our mean. Our mean is approximately 5.5. Now I'm saying approximately, not because I don't trust my calculator, but because of the numbers I put into the calculator. Those were approximations. My median, and go down to my list here, my median is 6. My mode, my most commonly occurring value, well, the most common interval was this one, so I'm going to approximate it based on its midpoint. So my mode is also 6. My standard deviation, back to the calculator we go. I'll go back up. We're using SX, so 1.85. Okay, and my IQR, back down again. We need Q3 and Q1. So we've got 6 minus 4 and an IQR of 2. Okay, the graphing calculator is a really handy tool, right? It saves us all that calculating power. We could do it all by hand. There's nothing wrong with it. In this case, you'd have to do, for mean, 2 times 8 plus 4 times 31 plus 6 times 42 plus 8 times 16 plus 10 times 3 divided by all of this. But it's way faster to type it in our calculator and use the technology to do our work for us. Okay, that's group data. Here's our homework, 4 questions. Nice and quick today. Hey, use the technology unless it says otherwise. It's a really handy tool. And if you're stuck with some stuff, come see me.